guys, it's Mrs. Anglade. This video is on lesson 8.3 part 2. And so today we're going to talk about the distributive property over, instead of multiplication, it's going to be over division, and it's going to be using addition and subtraction. Okay, so we're picking up where we left off yesterday, and that's on problem 3, splitting an expression equally. So they want us to take our algebra tiles and represent 4x plus 8 using our algebra tiles. So you can see that I went ahead and took 4 of my x's plus 8 of my yellows. And so let's go ahead and make sure that we draw that out with our sketches. And so here's my 4x, and here is my 8. All right. My pen was acting funny, so I'm having to use my mouse today. That's why it kind of looks really strange. Okay, so let's see what it wants us to do. It says divide your algebra tile models into as many equal groups as possible. Then sketch the model you created with your algebra tiles. Okay, so what that means is if I look at my algebra tiles, I want to look at and say, well, I want to make the smallest groups possible. I want to make the largest number of groups possible with the same amount in each. Okay, so for example, I can break this up into 2 groups of 2x, right? And I can break this up into 2 groups of 4. But is that the largest number of groups that I can make? Is there something more that I can do? Can I break this up into smaller groups? And hopefully you're saying, hey, look, I can make groups so that there's an x plus 2 in each group, an x plus 2 in each group. So let's see what they want us to do. Then sketch the model you created with your algebra tiles. Okay, so I, in each of my groups, was able to do an x and 2 of my 1's, right? So this is what I came up with. So the next part on C says, how many equal groups did you create? Go ahead and write down how many equal groups you created. And hopefully you said 4. Just write an expression to represent each group from your sketches in part B. So what they mean is, what does one of these groups represent? Hopefully you said it represents x plus 2, right? So verify you created equal groups by multiplying your expression from part D, x plus 2, and they want us to multiply that by the number of equal groups that I did, and that was 4. They want to know, do you get 4x plus 8? From yesterday's lesson, the distributive property says, yeah, I do get 4x plus 8. So now we're dividing instead of multiplying. So it says, let's consider the division expression from question 1. You can rewrite it using the distributive property of division over addition. Okay, so let's see what it says. It says 4x plus 8, and then I divided that whole entire expression into 4 equal groups, right? Let's see if I get a better view of this. Nope, I don't get a better view of this. Okay. So what does it say? It says I started with 4x. I made a group of 4. So let me make sure. So I started with 4 x's, and I divided those into 4 groups, right? And then I started with 8, and I divided each of these into 4 groups. And so what's left when I take 4x and divide by 4? I get 1x. And what do I get when I take 8 and divide it into 4 groups? I get 2. So that's what they're trying to show you whenever they write that right there. 4x divided by 4 and 8 divided by 4. So I'm dividing each of my terms by that number 4. Okay? All right, so the next question they said, the model you created in question 1 is an example that shows the distributive property holds true for division over addition. So they want us to represent 2x plus 6y plus 4 using your algebra tiles. Well, unfortunately, because we don't have any y's, I'm going to go ahead and show it to you what it looks like using what I have on my Mobi. So I have 2x, so I have 2x plus, was it 6y? I gotta go back and check. I'm not sure. 6y, yeah. 6y plus 4. And so what would that look like as a sketch? Remember that the y's are going to be a little bit shorter. The y's are going to be a little bit shorter than my x's, right? So 2x plus 6y look like this. So here's my x's. Ah! Oh, goodness. Here's my y's. And here is my 4. 1, 2, 3, 4. It says divide your algebra tile model into equal groups, then sketch the model you created with your algebra tiles. Okay, so let's see if we can move some things around. So do you see what we can do? Maybe can we put maybe this y and this y, and let's see, can I do this and this together? Let's see if I can make any smaller groups besides this. Let's see, is there anything else that I can do? I just have 1x plus 2y plus 2. Is there anything else I can do making smaller groups? No, unless I cut that x in half. So I think that's what I have as an answer for this. So here's my model. So what I'm going to have is I'm going to have an x. I'm going to have three y's, right? Is that what I had? I didn't have enough y's, did I? Whoopsie. I forgot to have 6 y's on here. Anyway, you get the idea. I'm adding a y over here, aren't I? I'm adding a y. Sorry. So I have a total of 3 y's. And then, I know that doesn't look any shorter than my x's, does it? And then I had 2 over here. So here's my x, here's my 3 y's, and here's... All right, so it says divide your algebra tile model into equal groups, then sketch the model you created with your algebra tiles. Well, I believe that's what we just did. I don't know what the difference between this question is, but sketch the model, divide into equal groups. So it says, how many equal groups did you create? Well, how many did I create? I created 2 equal groups, right? Write an expression to represent each group from part B. Well, what did each of these groups represent? It represented an x. And how many y's did I have? I had 3 y's. And then I had 2 constants left in every group, right? Verify that you created equal groups by multiplying your expression from part D by the number of equal groups from part C. Okay, so it's x plus plus 3y, and I had plus 2, and then I had 2 of those groups, right? I had 2 of those groups. So using your distributive property over addition, I got 2x plus 6y plus 4. My pen isn't working, so this is my mouse. That's why my handwriting looks so weird. I'm not sure why it's not working very well. All right, so yes, we do have that expression, so we are in good shape. Okay, the distributive property of division over addition states that if a, b, and c are real numbers, then a plus b over c is the same as a divided by c plus b divided by c. Rewrite the division expression from question 2 using the distributive property of division over addition. Then simplify the expression. So this is what they want you to do. They want you to write 2x, and I'm going to take half of that, right? I'm going to divide by 2. Then I'm going to take my next term of 6y and divide that by 2, plus, and then I'm going to take my last term of my constant and take that and divide by 2. So what is 2x cut up into 2 groups? That's just x, right? Well, what is 6y when I divide it into 2 groups? That's 3y. And then what is 4 divided by 2? That's 2. Represent 6 plus 3 times the quantity x plus 1 using your algebra tiles. All right, so I think at this point we could probably just sketch this out, right? So 6, and then we have 3 groups of x plus 1. So here's x plus 1, here's another group of x plus 1, here's another group of x plus 1. So what do we have all together? We have 3x plus 9, don't we? We have 3x plus 9. So what does it want me to do? It wants me to divide my algebra tile model into equal groups, then sketch the model you created with your algebra tiles. All right, so let's think about this. I have 3 x's and 9 of my yellows. So hopefully you agree that I'm going to make how many groups? How many groups do you think I can make? Think about factors. I can make 3 groups, and those 3 groups are going to contain what? It's going to contain an x plus 3, right? So that's the model that I came up with. How many equal groups did you create? I created 3 equal groups. Write an expression to represent each group from part B. I had, I forgot already. I had x plus 3. I had x plus 3. And so it wants me to verify that I created equal groups by multiplying 3 times x plus 3. And that hopefully you agree that that does give me 3x plus 9, which this is equal to, right? 3x plus 9. Okay. The expression in question 4, let me go on to the next page. The expression in question 4 can be simplified using the distributive property of division over addition in 2 ways. So I want you to study method 1 and 2, and I want you to explain the reasoning that was used in each. So do that right now as you pause the video. Okay, so method 1 was pretty interesting, and we probably don't typically think about it this way, is that they took 6 and divided by 3, and then they kept this whole expression, 3 times the quantity x plus 1, they kept that entire expression without simplifying it first, and they divided by 3. Well, if I have 3 groups of x plus 1, and I'm dividing them into 3 equal groups, don't you agree that each of those groups would have x plus 1 in them? So that kind of makes it a lot easier to simplify. Over here, what they did is they went ahead and took the 3 times the quantity x plus 1. That's where this comes from. Then they combined it into 3x plus 9. And then they finally divided each one by 3. You still get x plus 3 whichever way that you do it, but hey, it's all about how you see it and if it logically makes sense in your head about when you're simplifying these 2 methods. The distributive property also holds true for division over subtraction. The distributive property of division over subtraction says that for any numbers a minus b over c, what we can do is we can take a and divide by c, and then we can subtract b over c in order to find that. So, for example, if I had 2x minus 5 and I wanted to divide that by 2, I would take each term and divide by 2. 2x divided by 2 minus 5 divided by 2. Well, if I have 2 x's and I divide them into 2 groups, do you agree that I'm going to get an x minus 5 over 2? So it just simplifies to x minus 5 halves. All right, so part 6, they want you to simplify the expression using the distributive property. Then state which distributive property you used. Okay, so what are they asking you for here? They're asking you to take your 3x and they want you to divide that by 3. And they also want you to take your other term of 7 and divide that by 3. So if I'm taking 3x and I'm dividing them into 3 groups, do you agree that I would have 1x in each group? And then minus 7/3. I can simplify 7/3 into 2 1/3 if I want, but typically we just leave it as 7/3. So which property did I use? I used the distributive property of division, right, because I divided, over subtraction, because this was subtraction. Go ahead, I'm going to pause the video. Go ahead and see if you can figure out each of these. You can do them several ways, but I'm going to show you the way that I would probably do it and see if you get the same answer if you don't necessarily do yours the way I do mine, okay? So go ahead and pause the video and do parts B, C, and D. Okay, so here are my answers for B, C, D, E, and then I do have E on the next slide. So if you haven't done E, go ahead and do that right now. Part B, I went ahead and I kept that 2 quantities of x plus 4. I kind of like that whole idea of, well, if I have 2 quantities of x plus 4 and I divide by 2, I'm going to end up with 1 quantity of x plus 4. It makes it a little bit easier for me. So I got x plus 7 for part B, x plus 8 for part C, x plus 7 halves for part D, and for part E, I got, in simplest form, x plus 5, because I had an x plus 1 when I divided this by 3, and I had a plus 4, and combining like terms would give me x plus 5. So that is the end of lesson 8.3. What I would like for you to do now is go and do parts D and F from last night's homework that I had you wait on to do, and I would like that turned into the turn-in box when you complete that, please. Parts D and F on assignment 8.3. Finish that now and turn it into the turn-in box. After you finish that, you can work on your Moose math. Thank you.